All right, so to finish off the multiple choice part for 4.1 through 4.3, question 1, the function t is given by f of s, models the time in hours for a sample of water to evaporate as a function of size s, of the size s of the sample measured in milliliters. Wow, I don't even understand what just happened right there. So we're trying to what are the units for f double prime? So let me get a grasp on what the units are. So I can say that f of s is measured in, so if I were to imagine this as a graph, we would say this is s, and it seems like t, which is equal to f of s, is time in hours. So this is hours, which is odd for a problem to have time measured on the y, but I believe I'm reading that right. So the function is t. So the y so these are t's and f of s in hours. And then we can see that s, which is the independent variable, so the inputs for the function are milliliters. So this right here would be, so this is milliliters. Okay, so f of s, we're saying, is measured in hours. We're saying f prime of s, which would be equal to hours per milliliter. And that means the second derivative of s would be equal to hours per milliliter. Oh my gosh, I don't know how to spell this word. There's too many L's and I's. Milliliter. Per milliliter. I swear I have to write that word again. Milliliter. So hours per milliliter. I think that's got to be C. Okay. Okay, so for 2, we're going to need a calculator. So we're given the function there. The function d defined above models the depth in feet of the water t hours after 12 a.m. in a certain harbor. Which of the following presents the method for finding the instantaneous rate of change of the depth of the water in feet per hour? Wait, why do I need a calculator for this? Oh, I guess to actually find the derivative. So, which is the correct one? So basically, it's not going to be A, because that is the average rate of change. It's not going to be, which of the following presents the method for finding the instantaneous rate of change of the depth of water? And D is defined as the depth. So the instantaneous rate of change of the depth, that's got to be the first derivative. And so I don't see any other option than to choose B then. Not necessarily sure if that is 0. Here, let's try it out. So we've got 10 plus 4.9. 4.9. Cosine of pi 6t. So cosine of pi divided by 6x. So we've got this right here as f of x equal to, and we'll do f prime of 6, I think we said. F prime of 6 is indeed equal to 0, so that's good. I think it's got to be that one then. So we'll roll with that. Okay, a particle moves along the x-axis so that any time t is greater than or equal to 0, its position is given here, where a is a positive constant. For what values of t is the particle moving to the right. So notice here that they don't give us any actual values. This is just talking in generality of the given function. So, but what the important part is the concept, and the concept of for what values of t is it moving to the right. What is important to note here, a particle is moving to the right when the velocity, so v of t, is positive. So that's what we want to figure out, when v of t is going to be positive. So let's go ahead and just take the derivative. So we know that v of t will be equal to x prime of t, which will be equal to, we're going to have to use the power rule, so we'll have to bring the 2 over here. That's going to cancel. But we're also going to have to use the chain rule. So it's a minus t times by, now a is a positive constant, so that means when I take the derivative of the inside, that's going to be 0, and the derivative of negative t is going to be negative 1. So we can say that the velocity, v of t, is equal to negative a plus t. And when velocity is positive, so when this is positive, it will be moving to the right. So let's see which of these, or what I need to do further here. So the particle is moving to the right between 0 and a. That might be it. But let's actually, maybe we'll add a over here. So when t is greater than a, so that's the same thing as this right here. That's the same thing as a is less than t. Yeah. I think we've got it as b then. It's got to be b. I think that matches it. Okay. So yeah, we're not really using any values here. But yeah. For 4, a particle traveling along the x-axis has the position x of t at time t. The graph of the particle's velocity is shown. So this graph right here is of velocity, not of the position. Which of the following expressions gives the total oh, wait a minute. Did we talk about total distance in class? We absolutely did not. Oops. That's my bad. Okay, I'll do my best to explain this then. So, total distance traveled, is, so when you think about displacement, it's not, you don't subtract values. So if you are moving to the right and to the left, the displacement will just be what's happening here. So you're starting at position 0, let's say in a horizontal line, you move 10 feet to the right, but then you move 5 feet to the left. Your displacement is 5 feet right here. But the total distance traveled would be 15 because you moved 10 and then you moved 5. So that's the total distance. Okay? So which of the following gives the total distance traveled? So if you remember that velocity, we can, that if velocity is positive, we're moving forward, and then we're moving backwards here. And so what we want to keep in mind is that, yes, we are moving backwards here, but for distance traveled, I pretty much want to add both of these parts. I want to add what's going on here. And so what's the best way to kind of explain this without ever having to explain total distance travel to you guys? So let's say this right here. Oh my gosh, I shouldn't have assigned this because it's hard to explain. So I know it can't be A or B. Notice the notation for A and B. We're talking in terms of x, which is the position function. So this says the position at 3 minus the position at 0. So that's basically saying right here, basically saying the change in position from 0 to 3. I take my positioning at 3, subtract the positioning of where I was at 0. And that will tell me the distance from that's happening from 0 to 3. And then That's basically the same thing that you can do over here. You'll take the distance I am at 5, subtract the distance at here at 3, but technically you want to do that in the reverse order so that you're not subtracting it. So that's why I don't think you want D here. We don't want D because the order in which it happens here. So another thing to note about the velocity right here is that velocity is positive here, yes. You can also see that velocity is decreasing, which means we're slowing down. But in any case, actually I don't think that matters here. No, that shouldn't matter. But because we are positive, because velocity is positive here, we're moving forward, which means if I take the positioning at 3 and subtract the positioning at 0, it will be a positive number. But if I take the positioning at 0 and subtract the positioning at 3, that will give me a negative number. And because we're dealing with total distance, I don't want these parts to be negative. And that's why I also don't want this right here to be in the order, because since we're moving backwards right here, the positioning at 5 will be a more negative value than at 3, or be not necessarily negative, it'll be a lesser value. So then whenever I subtract a lesser from a greater value, that would be negative. So in any case, I didn't really teach this in class, and I totally forgot about total distance traveled, so that's my bad. But hopefully that was an okay explanation. But the thing about total distance is that it comes up more in chapter 6 or 8, I can't remember. So I don't think I'll be talking too much about it until then, because it's more of a concept that we talk about later in later units. So, okay, let's finish the assignment by doing the fifth example. So an object moves along a straight line so that any time t from 0 to 8, its position is given here. For what value of t is the object at rest? So the object at rest, that should tell you, that's a key phrase for us, that should tell you when the velocity is equal to 0. So, and we know that velocity is equal to the derivative of position, which would be equal to 4 minus 2t. I set that equal to 0. So when 4 is equal to 2t, so when t is equal to 2, and so that's going to be A. And that should do it for this assignment. Again, sorry about question number 4, but what's done is done. So hopefully that helps.